All right, we are in the second part of the Unit 4, which is I/O organization. So in this second lecture, we'll start with asynchronous data transfer. Okay, asynchronous data transfer. The sender provides synchronization signals to receive before starting the transfer of its message. All right, it does not need clock signal between the sender and the receiver, and it has lower data transfer rate as compared to synchronous data transfer rate. So synchronous data transfer hi kan soitur so ania asynchronous data transfer. Synchronous data transfer the synchronous data transfer hi in opposite si ania. Synchronous akhatson arualin ani dona asynchronous akhatson arual kerlawin ani dona ni chu mizo chunga ka soi fiat he dan ani asynchronous data transfer kan ti khatsuan data pek sang in lo chen tai la pek khat kha kal ma sanga adang pon ti khan arual te ponan kalanga arual lo pon kha asynchronous data transfer ani synchronous chuan arual vekin ti khan transfer don ani chuan asynchronous data transfer hi amuang zok ti kha in le kha bu si ala ani Now let's talk about strobe. Now strobe enge strobe ti kha kan soidona. A strobe is a pulse signal supplied by one of the units in asynchronous data transfer between two units to indicate to the other unit when the transfer has to occur. Okay, strobe kan ti chuan signal pakhat soina kha ani asynchronous data transfer khan pulse signal kha strobe tinia chu athon tu emo adong tu emo khan andu huna an pe chuak theita ne athon tu khan ti khan strobe kha kalau thone ti kha avashila ti khan athon mai theya adong tu po khan kalau dong ti asya theina kha strobe signal ani chu. There are two types of strobe. The first one is source-initiated data transfer, and the second one is destination-initiated data transfer strobe. All right, we are going to study these two types of strobe in details. The first one is source-initiated data transfer strobe. As you have seen in this diagram, the first one is block diagram. Okay, the source, there will be data transfer between the source unit and the destination unit. And since it is the source initiated data transfer, the source will send data through the data bus and will also send strobe signal that I have sent the data to you. Okay, this is the timing diagram. So as per the timing diagram, data has to be put on the data bus first, only then the strobe has to be initiated. Okay, source initiated data transfer hian data khakanin ton tir don tani khoya changin khoinge kan ti source le destination ain kan soita source khantinan keyboard lo ni ta se destination kha CPU lo ni ta se keyboard khan thila thon don cha athon papa chuan chu data bus athon anga chuan kalau thon nge ye ti shiat na kha a omangai ta chumi chu source strobe ti ni ta chu athon to no kalau thone ti kha vashila chu source initiated data transfer ani zia pera chuan kan chiang tur akangai a diagram tenen kan ti lang thapa. Another one is opposite of that one, destination initiated data transfer. Okay, destination initiated data transfer, the destination unit activates the strobe pulse. Okay, destination initiated a ve thung chuan initiate tur chu adong tu tur khan data milo thon to ta che avati don ta ne chuan athon tu khan athon kami strobe milo thon to ta che ati na strobe signal awang khan data vathona chu destination initiated data transfer tia ming fu le kha ani a timing diagram in n chuan khoizo nge masazok in shed du chuan eta hian strobe khan dong tu lam khan milo thon to da che avati masapot da chuta chau khan athon tu khan data kha ti khan avathon chau don ti na ani chu I hope you understand in Shethiam MO hey tam fe in le khabu en ziaka no da po kan le in pedona chuan in chiaranga in Shethiam mai abe sei atlang pui thuak karon soi ani chu so these advantages of strobe method chatlo na te
sorry screen share lo mo le ka
ani mo investoi harve I am very sorry for that. Actually, you should have told me before. Ikanin mo tayo em?
Yes, sir.
Ale. Ani, Joan, atoy join kan soy no le ang asynchronous data transfer at Joan arwal kerin ang kaltura nila data ka. Synchronous at Joan arwalin ang kaldon ta. Strobe kan ti Joan engem mo signal in pek za ka strobe kanimay. Joan ma source initiated data transfer strobe le destination initiated data transfer strobe ma source initiated data transfer strobe at Joan hemi diagram currently lan angin athon tu khan data kha vathona nga chuan adong tu ne na data karon thona nia o avati kha strobe na lai data tello ma karon thon avati kha mi signal kha avar thon thu kha signal in indicate don ta dong tu ne na chuan chu source initiated strobe tinita destination initiated ave thung chuan adong tu tur lam khan data lo ma mo to nyang data mi lo thon to ta che avati a thon tu khan ti khan thon a chu destination initiated strobe ni asap chong chuan the in source initiated the source activate the strobe but in destination initiated data transfer, the destination unit activate the strobe. Okay. Now disadvantages. The disadvantages of strobe methods are the source unit that initiate the transfer has no way of knowing. Kasi lo may nga ani dan tak mizo join kan so if may nga source initiated strobe akan data ka avat daa data basa chuan strobe mangkhan kalau thon che ti vashil ring ata adong tu lam khan adong nge yem ti chian theina kha anei lo chu a that lo na chuan destination initiated ve thunga chuan and the source unit athon tu khan data kha dong nge yem ti kha a hriat theina nei chuang lo data kha vada top ta chuwang chuan communication kha a om thei lo chu na ani ber. Now let's talk about handshaking method. Okay, handshaking method. So the data transfer into a bus with a control signal indicating the presence of the bus. His one handshaking method ave thung chuan data transfer kharon ta a signal ne data bus and data when the receiving unit receive the data item it responds back sending another control signal to acknowledge the receipt adong tu lam khan data andon vele kalau tong nge ye ti khan strobe signal strobe ni to chuan lawin heta handshaking a chuan adon nge thu signal in a vashil leta chu handshaking anti athon tu in data da kalau thon nge ye ati a chuan adong tu in alo donga adon zon hu ka donge ti avashil le khan ti khan handshake om theta chu wang chuan strobe method ai chuan a thazok ti na ani chu handshaking method. Okay, so there are two types of handshaking. just like the strobe, source initiated handshake. Source initiated handshake. That's one. The source set data request. Source lam khan data karon thon du e at the potanga. Source make valid data available. Then the source te khan data kha ada anga. Destination read data after a few delay. Okay. Destination lam khan khatianga data omta chuan avari tanga. Destination send acknowledgement signal to the source. Kalau dong ye ti kha athon tun hen athon nga the source stops sending data. Chuan source lam pangkhan athil thon kat top tonga destination reset acknowledge signal. Destination khan acknowledge signal po kha ati topang. Chu source initiated handshake ani. Example kantidon nge diagram chuan hetiang song hian le khabuin aron ziaka helampang veilampang hi source unit ani a dinglampang hi destination unit ani a. Source unit can place data on the bus, enable data valid. Bus khan data data tu kha ashila. Chuan destination lam khan data kha bus atangin allow la chuan data accept tu kha source avashil ta. Chuan source lam khan data kha lak thei to lo turin athon lai at the top chuan invalidate data on the bus data khatipawa. Chuan destination lam khan data kha accept ta this one adang accept thei turin en siam rem chu ani de permai. Now the destination initiated handshake. The destination device output data to the source. It makes valid data available, and destination read the data after a few delays, and then destination then data signal to the source. The source stops sending, destination receives ready signal. Okay, at the vetu is one destination khan bulatan timay bularon chananga. And destination device output data to the source. Destination destination lam khan data data itlai kan ti hi data ka du ti vashil na signal khan de permaya chuan source lam pang khan data tu chilanga destination khan data engemaw delay zon hu ari tanga chuan destination lam khan a receive tu kha ti khan thon lenga chuan stop signal te destination in signal kha reset on ta chu destination initiated handshake ani ve thung ta ni picture chuan hetiang song hi ani ta destination chu atimasatu ani ti kha sheta ila athange. Now we have studied 4 important points. One is strobe. Okay, strobe. Source strobe and destination strobe in SOAR. Another one is handshake. Here we have source handshake and destination handshake. I hope it's clear to you, and if it is not clear to you, you can ask me anytime. Okay? Kha ay soito tam tak po kha la amarotsu kan soito lo me nga inche tiam tau ka base ito na chan modes of transfer. Soito taila. Data transfer between CPU and I/O device may be in a variety of modes. Here we are talking about data transfer between the CPU and I/O devices, okay? Not from Silong to ISO or something like that, okay? And some modes use CPU as an intermediary part, and other transfer the data directly to and from the memory unit, okay? Utilize it. So CPU alaya intermediary til laudong song tu khan computer modes chin kara chon om thea achena chuan direct takin direct so IO device atang in memory RAM at the direct in the. So there are 3 modes: program IO, interrupt driven IO, and direct memory access IO. These are very, very important, and they usually ask in university exam. Okay, I want you to listen carefully. So first of all, let us try to study what is program IO. Program IO chungchang hitlem say kantu mga CPU request IO operation. CPU khan IO khan til amamo tu engamo kha ava request don tani IO headline kan so hian input output device tin han eng device po ani thei okay eng device ka tiam ja chu printer po ni thei speaker po ni thei ani lo le microphone po ni thei computer ne na connect thei song song khani thei tani IO module performs the operation IO module khan kha CPU request ka lo shianga operation ngai kha lo ti don ta IO module set status bit IO module khan ati zo ma chu la ti zo lo angin status ka setanga chuan CPU checks status bit periodically ati zo to nge ti zo lo CPU khan chang in ava check le se uzewanga IO module does not inform CPU directly IO module khan direct takin CPU kha ava shelawa IO module does not interrupt CPU IO module khan CPU kha ava tipwai lawa omzia chu Misotron color CPU may wait or come back later to check IO module status. Okay, now let me try to explain in Miso program IO chungchang Misotron in atoi thiang berin han soi tum ta ila CPU khan IO atang in enge mokha mamo tani chu amamo kha CPU khan athon ta IO module khan allow shia ti allow tum tani chuan ti don angin ti khan status bit kha check ta busy ang khan lo om ta se chuan CPU khan na tang alo thok charanga chuan anaka lak azo kar lak lo khan IO ka thil request ka zo to empty kha ava check le sel don ta ni chuan IO module khan lo zo to po ni se CPU na thok lai kha ava ti buai don lo wa ka zo to hei thil do chu kan nei ava ti don lo wa status khan zo to status kha set ringot don ani chuan chu tiang ani chuan IO na tho le CPU na tho kha shanania CPU khan ti buai mi alawin na danga tho theanga chuan chu na tho so kuna khan IO a request ka data kha apala theanga chu program IO kalphum ani heta hian diagram nen current lang le hemi kan subject hian diagram hi apoimo MZU exam huna po yan diagram nena draw to ti ka hi akal du lu tu ka chu wang chuan diagram nena thil sheet to ka du dan phase en chon a diagram kha bai hat to pula a thu kha chu diagram atangin a phua the zo ani kha injir dan to ra ka du dan ani IO module thleng chi kha ka soya tu na khan IO module khan a tool chuan IO device te kha va request the zo kha program IO na tho dan ani insert thiam emo insert thiam le thiam lo ran soi te ule ava fiam me lo ve khoi lang nge soi nan lengai avai in ti chu ni lo ka be se soi nan du in nei chuan ran soi te ule ka repeat theye program IO chau hi mi in very less all right program IO big te hi ma soi nan le ngai Misotron sai me hemi diagram atang hian soi tum zok tai la thange CPU hian thil na tho den ron re rengin mamo hi nei thin ani chu amamo chu antenna register le RAM vel random access memory vel om chu ni ta seng chuan avala mai all something avala mai thin ta ni amaro chu IO atanga mamo lo ni ta se IO atanga mamo kan ti chuan example kan pe anga afia zok le zol nan nangma decision kha computer ina mamo tani zo na ron zo cha do you want to continue yes le no click to te khalo ni ta se shathiam mouse mangin CPU khai shilangai don tani chu CPU khan is azo na yes or no chan na kha amamo thu kha IO device module nena khan ashilanga kha module khan yes I click nge no I click kha allow n call to topani chu avash CPU khan avashil zuaya chuan avashil to nu kha chuan an nadang tho tur tam tak kha alo thok ta a chuan nangman yes le no I click ma kha chu IO module khan a status khan not ready ti emo busy ti emo ani photanga CPU khan an tho kar lak lak a chang in IO module khan ati zo to emo ti khan avachek ve zeu zeu ani chu avachek ve zeu zeu ta CPU ti po ani lo chuan chu ta chuan nangman yes te lo click ta la CPU khan aron check le huna khan yes signal kha IO module khan amudona ti chuan an na tho lai dang alak lo om to lo dona wangin ti khan khami yes le no azir khan na thok chun zom thei don tani program IO a chuan IO module khan CPU na thok lai avati boy lo chu ani de ber mai atoi zonga soi chuan kan che thiam ang tero yes or no please
Yes, sir.
okay now these are the different characteristics of program IO module continuous CPU involvement tiom zia chu CPU khan avachek de chen kha ngai don chu wan chuan CPU kha a slow endina enga chak poni se heta avachek chen chuan IO lampang speed amwang box ya chu wang chuan speed nen khan CPU chak via poni se CPU chak lawang in om don ta simple method for data transfer simple hardware amamo tlema chu wang chuan computer efficient tak ani lo khatiang zonga program IO zonga computer kan design don chuan CPU chak na kha khan mang cha fum fe don lo ti na ang ani mai now interrupt initiated or driven IoT kan soile interrupt initiated or interrupt driven IO chungchang hi soile ta ila athange ka zo chep to in ka shia lo ning ri lo la zo man katum ani CPU issue read command to the IO module. CPU khan amamo thu kha read command kha IO module avape IO module get data from the peripheral while the CPU another work. CPU khan IO module khan CPU mamo kha peripheral satangin ala CPU khan nadang alaw thok chun zomta get this IO module but check let's chen lo khan after getting the required data IO module interrupt the CPU chuan IO module khan CPU mamo ani huna khan CPU ne na khan avakala avati boy na tholai nei poni se hey imamo chu karon te avati boy tani CPU requests data to the IO module and IO module transfer the data chuta chuan CPU chuan in it is on thon ta che ati a chuan IO module khan CPU ne na khan data thona chu interrupt initiated or interrupt driven IO in it hey a diagram chunita method pan hi kan zero CPU le IO module incarnate tho dan po chu khoi zo nge thazo ka in shia CPU khan ava check chen nge tha anga ani lo le IO module khan already huna CPU na thoklai po vati buain hey imamo ka nei to avati kha khoi zo nge speed chak zo kang ti kha hardware designer lo ni tala ingai to sok to chu ani in shethiam interrupt driven IO2 hey different characteristics ani CPU khan anga char tur kha a om lawa nadang alo thok theya chuan no repeated CPU checking repeat IO module kha va check reng kha ngai lo boka chu wang chuan a that zok na a om ani chu okay atazoka there are various types of interrupt yomzia chu IO module khan CPU avati boy kha interruption ani tane chuan interrupt he chang oma priority interrupt by software which is called pooling software in ava interrupt khan chu pooling tinita priority interrupt by hardware in interrupt chu chiniom le chu serial and it's one daisy chain priority parallel and it's one hardware interrupt vati boy dan vati buai ringot po kha chithum mi na chen the ni so software ni chuan polling 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 tin ya hardware a ve thung chuan daisy chain priority le parallel hardware interrupt ka a on thei bok ani. Now the third type, the third and one of the most important type is DMA, direct memory access. Okay, direct memory access chung chang hi kan soile to don ta DMA. The CPU grant IO module authority to read or write memory without its involvement. Headline hitil poi mo tak chu litani. CPU khan IO module na tho enroll reng khan ana tho tur athok theilawa. So an CPU khan na athok dona IO module in avati boy reng po khan amuang dona chuwang chon ti dan dangan ngai to an ti dan mu chu ber chu DMA hi tani direct memory access hi ani tani DMA chuan CPU khan antina CPU hi principal ni ta se principal khan vice principal nena ikuta kada atito panga no vice principal so IO module lo ni ta se student related vel mai mai chuan vice principal in thune na top kha keng don tin ani tani heta ve thung chuan CPU khan IO module ne na memory read le write kha phal na kha pe top ta chuan CPU kha enroll to lo IO module the chang in memory athil da ngai lo om ta se direct takin CPU involved lo in ada top the chu DMA chuan apoi mo lai per chuni tani DMA module control exchange of data between main memory and IO devices. So if there needs to be some data exchange between the IO devices and the main memory means random access memory. Okay, there is no CPU involvement. Only the IO module can do that. Okay, CPU only involved at the beginning and at the end of the transfer. At to atir lai berale topa khan CPU kha involved chau don chuti lo ain kar laka khan afa involved don lo ti na DMA chuan hei hi a diagram chu ani a soidon taila soitur tamanga DMA b ka hian DMA controller hi apoimo ta parallel chuni tani heta hian input output devices ho hi o manga dinglama hian example enti ranangin DMA request avak tianga DMA hi CPU ang deuh ha anito tani DMA ha DMA controller hi chuan avai first time ani chuan CPU kha DMA hian avazotang ka phalsak don em tianga yes ati nu kha chuan data transfer song khan involved to lo inti khan transfer charge sar theyanga azo huna chuan DMA hian adule CPU kha fa interrupt de zewanga kan zo ta avashil thei don tani hela ma random access memory om hi chu the IO device changa random access in kara data transfer to nita se direct takin CPU involved lo in hian transfer thei ti na ani Now, the DMA controller is a special hardware that manages the data transfer and arbitrate access to the system bus. The controller are programmed with the source and destination pointer, counters, and different settings for the IO devices. As I have already explained, the DMA controller is a special hardware which like the CPU, okay? And the DMA transfers takes place between the IO devices and the memory devices. So it may be the DMA write operation or the DMA read operations. And DMA controller takes over the bus because we need the bus in order to transfer. Okay, so it can be studied a little bit in detail. DMA operations, DMA tell CPU tell the CPU, the DMA controller to read write device address, starting address, and amount of data to be transferred. CPU carry on work and other works. It doesn't care about what the DMA is doing after it is giving the permission. And DMA controller deals with the transfer. DMA controller sends interrupt when finished. Hi mizotra ka saifia to thau kha ani in chethiam DMA controller chung chang kha ale in chethiam chuan I think this is the last part.
Yes.
Yes, I think we almost finished. We have around 7 minutes. So within this, I hope I'll be able to complete input-output processor. Kan say to thum do na ni processor hi computer hi na poi mo lai ber ani input output in na an tho do na processor avati boi chen kan input output ho kha device muang lu tuk chi an ni box sia chu wang chon computer song so amwan perfect the awang in input output processor hi idea pakhat aran chuak kan chu tu na kan say tum hi ani ta ni the input output processor can execute a specialized IO program residing in the memory without intervention of the CPU. Heta po yan atil tumpere to CPU vati boilawa input output processor mga input output devices sa ukan na anto te na anitani. CPU only needs to specify sequence of IO activity to IO processor. Dito na DMA controller kan so yang ukan input output processor po yan CPU telawin CPU kan atirin ti tursong katuk sa kanga chuan siya input output processor yan allow tifek kanga ati iso huna kan input output processor hiyan CPU niya na kan actually may don ta chu input output processor siya ani idea pakhat dang le ani chu DMA controller mang lawin input output processor mang hin ti khan thil atho the don ta ni chu wang chuan processor pani pathum ang pon a soi the ang chu processor tak chuan DMA controller kha processor ang ina ngai the bokanga chuan chumi lo idea dang a chuan input output processor hi processor dang le ta chu wang chuan they needs to communicate okay anin biak po fo wanga ya chu input I think I say don inter-process communication tikha tani inter-process communication so the communication between the CPU and input-output processor is known as IOP, CPU IOP communication. Anin communicate dan so heta hian atoy song in le khaboy na rantar landan karon tilanga CPU chuan instruction part kathana so until transfer ngai ang kha shila a bulletin and it's a CPU and a bulletin IO operation kanti ngai allow ti ati so huna okay to have a leta chuan ati ngai ti khan ati sel atop kha chuan CPU tho kha athunei tu kha ani ta tho ani a detail lutuk chuan ti khan ka sei lawanga khati song kha ka sei thei ni se lecture here today in my talk one. I hope you have enough idea about what we are talking in short term ngay ka basic ani input output processor po khan thil activate ta na amaro chu atir bera khan processor thulo chuan bul achan thei chuang lo processor in bul achana input output processor kota input devices le output devices whole ne na thil ti ngai kha chu lo en culture sarang atopa khan processor bok khan akhar na kha ani le angai ti na ani chu ole ti khan kan che thiam o zo na chuan zo dula lem lo chuan khatu tok mai don nia recording ka stop to nge